Hello, hello everyone. Face detection and recognition. Here we will see about the face detection, how it will work, how can we use OpenCV, what are all the different techniques available to detect a face, and how we can achieve using the Python based programming with the OpenCV. Brief introduction about the face detection. Face detection is identifying the face region of area in a digital image. Basically, if the image is given, whether the face is available or not, that it has to identify. That is the main purpose of face detection and a specific class of object detection. Face detection is a specific class of object detection. Something, if we take a smartphone or a mobile phone, how we will identify? We will identify if there is a keypad, if there is a touch screen, or if there is a LCD, and if there is something like a small kind of phone, we will identify with that object is a mobile phone. Similar way, how we will identify it is whether it is a face or not. Yeah, that is the typical question. Basically, that it's something like it should have nose, it should have mouth, it should have eyes, it should have cheeks. With that only we can identify that object is a face. That's that's it. Basically, we will identify that location or size of the human face. For example, we can take the image in the close-up, we can take the image in the longer. It has to identify that face is present in that given image or not, whether what is the location of this face and what is the size of the face. If the digital image is taken too far from the face, then the face will be very small, and it can also be a big if it is taken very close, and it has to detect that accordingly. Yeah, that was the key of face detection, and focus will be mostly on frontal face. We may not know, for example, if we have that back of our back head, we will not know how we cannot able to identify. Basically, there is no features available like a nose or mouth or eyes. That kind of features is not available. It's completely a black. Then we cannot able to identify that it is a human face or something like some small what we can say, that something like only a hair of give and that a makeup hair glove, or it is a face, we does not know, right? That was the key difference. We wanted to identify only the frontal face of that face, basically. And also we can do that detection of the other following things. We can do that human eye, we can do that upper body and lower body, and then we can detect that full body and then smile of the face. Basically, that we will see over there. We will see about that face detection techniques here. It's a feature based face detection and a geometric based face detection and higher like feature based face detections, basically, and high level language. Or suppose, for example, I am using Python for programming here. What is that it supports? Basically, that it based on that Python supports OpenCV. Based on that face detection, we shall do that, and we can do that comparison over there. Feature based face detection is something like a feature like eye, nose and mouth. That detection it has to do, basically, and with respect to that location it has to detect that whether it is a face or not. And we can also do that geometric based face detection, which means that skin color, based on the skin color, and with that we can able to extract that features and selection based on the geometric combination that we can able to do. Basically, that in that case, for example, we have if we are basing with the skin color modeling filter, for example, if your face is in very bright, then it will be different. It will act as a different case. If it is in your dark, it will act as a different case. For the skin color modeling, it has some disadvantages. And going forward with Haar like feature based face detection, cascade detection process to increase that detection rate basically, and it has that multiple detections which is in the cascade. If one get failed, then it will skip that face basically, and basically that it will extract that background image and get detect that face accurately. And it has will provide the threshold and value in the current stage to do the further decisions. Something like we will get that threshold or probability whether it is a face or not. Based on that, we can able to detect, we can assume that it is a face or not, that we can able to do there. And we have some theoretical comparison between the different techniques here, approach and parameters. And we have hair-like face detection and geometric based face detection. Accuracy wise, hair-like face detection is higher than geometric based face detection, and the detection time is lower. That means it can execute in faster time, and it has execution time is very low, and then the geometric based detection, and the learning time for the face detection is higher. Something like, anyway, that learning time will be we will do that model and we will feed that into that hair like face detection. Since that learning may take maybe if it takes a month also, that should be fine. Then we can continuously use that with lower detection time basically. And that a lot of research are going on to lower that the learning time basically, and the detection and false alarm is higher basically. Detection with respect to false alarm, it will detect always higher than, it will not give false alarm, it will not give false alarming, it will give more accuracy, correct alarm, higher correct alarming will be higher for higher hair like face detection, and the geometric will perform little lower, it can give more false alarms basically. For example, some textures are available. For example, you can able to see there is here there is my face shadow is coming. It can also detect it as a face in case of using the geometric basically. That can able to do. For example, I can show it something like this, so that my nose is in the shadow. It can also be detected as a face detection with respect to geometric based detection. That will give that false alarms basically. And we have that pros and cons of existing methods. Something like different techniques. Feature based detection is more accurate, lower execution time, but it has that higher learning time. And geometric based detection has efficient design and easy to implement, but lower accuracy, and it has more false alarms basically. And hair like detection has improved feature extraction, less false alarms, higher execution time, and complex to implement, which has that hair like detection is more popular with respect to OpenCV basically. That we are going to see how that hair like detection will happen, and what is the algorithm it involved to detect that face basically. Yeah, here we have Haar cascade classifier, an efficient object detection method, machine learning algorithm with the cascaded functions, trained with lot of positive and negative images. For example, positive and negative images. For example, we can say that if you wanted to detect a watch, then watch is the positive image, and the negative image something like I am wearing a watch. For example, I can show you this way basically. I wanted to detect this mobile phone basically here, and this is the mobile phone is the positive image, and if the phone which I am carrying the phone completely with me, this is the negative image, so that we can able to detect if I am holding a phone or if I am holding the if I'm keeping it somewhere here, somewhere here, and something like this, I couldn't able to detect. Basically, that's kind of a positive and negative images. In case of face detection, I'm having the face here with the white background over there, and maybe I may be in the place somewhere else. It can have jungles also. I can be in the forest, there will be jungles, and with that also, yeah, my face is the positive image, that with the jungles background, all those things contains, it has the negative image. So that the when we are doing the detection, we have to extract the background and get our faces. Basically, maybe that in real time we does not know the face will be in the jungle, or face will be in the shopping mall, face will be in that classroom, face will be in that everywhere. It can be that it can that's things we can put in order to create that model. We have to make that model something like face detection with the positive images, lot of negative images, that will create a good accuracy. Basically, that we will see here that how we can able to detect a face. Then in the further sessions we can able to explore that how we can able to create that model, that we can able to explore that furthermore. Yeah, here the trained data basically will be used to detect that objects in the given image. Basically, once the trained data is given, then we can do that different comparison to get that whether the objects is face is present in the given image or not. That it can able to do with respect to that Haar cascade classifier. But something like Haar cascade classifier will act as a one by one, that we will see in later case. Here we have that rectangle window feature, something like edge features, line features, and 4 rectangle features. Something like we will have to detect that face, that it has to do the edge detection of the face, and then eyes, and then nose, and then mouth, that it has to detect with the edges, and it has to get that accordingly. The face should be detected by the program. Basically, for that it has different features. It has to be extracted like edges and then line. For to detect the nose, we should have detect the line, and then we have to detect the cheeks, so that it has to be 4 rectangle, that it has to get detected. Basically, that with that concepts it will detect that rectangle window face based features. And we have the cascade classifier. Cascade classifier is multiple classifier is in cascade. Basically, for example, when we are giving that new image to the classifier, if it says whether the face is present or not, if yes, it will be given to another to further processing, so that it will have less execution time in case of if it got skipped in the first time itself, and if it will take some more time to confirm whether it is image face is present over there or not. Yeah, and for the Haar cascade classifier, we have been trained with thousands of frontal faces. As we discussed, you should have frontal faces, thousands of frontal faces, and millions of non-faces. Something like negative data. Non-faces in the sense it can be in the forest, it can be in the shopping mall, it can be in that somewhere else. That has that more value. With the millions of non-faces, we have the training data contains that thousands of frontal faces which is needed, and whichever the negative images, something like background, different things, so that we will detect the face in any of the conditions. Basically, it has the normalized faces, and feature encoding is something like a location and size of the face, and light intensity used to capture that face. All those things has been fed to create that Haar cascade classifier XML based data that we will see over there. And also that in order to detect that face, we will do a mechanism called integral image. Integral image is something like sum of the images, so that the 4 pixels are there, then we will do that sum, so that we will get that average intensity of the given image area. That works better with the grayscale. That's why when we are doing the programming to detect our face, we will convert that no, we will convert that our color image into the grayscale, so that to get the better results over there that we will see. And we have OpenCV classes and the functions to detect the face. Basically, we have cv2.cascade classifier, which detects that objects in the frame that depends upon the training data we are loading. For example, if you are loading a training data with the faces, if whatever it detects is the faces. If you are loading with that training data with the full body, and it will be a full body detection. If you are loading with the training data of smile, it will detect only the smile. If you are loading with the training data of eyes, it will detect the objects of eyes. Basically, that was the cascade classifier works. And then it has the function called detect multiscale. It's something like we can have in a single image, we can have a multiple persons can be in a single image. For example, multiple eyes. Even for a single face, we must or may have at least two eyes or single eyes that it has to detect. Means it has multi-scale. That's something like it will detect multi-dimensional arrays, so that it multi-dimensional list list of rectangle areas, so that we can able to detect the location and size of that the object present. For example, in case of a face detection, we have one face here that it should get detected with the this much. For example, I am going away, when then my face got small, then my size will be a small, and then I am coming here closer to this, then my face become bigger. That it has depends basically, that we can able to see with that programming labs over there. And it has that different parameters that it has to be given, that it's something like a image matrix in which it has to detect that object or face. And it has to be, we can give that configure that scale factor, how it has to be shrinked to each scale, image scale, that we can able to give. And minimum neighbors, for example, something like we have that how close that your neighbor object will be present, whether there will be very closer or very little bit distance. All those things that we can able to do with this, playing with this here. And how many neighbors each candidate can have, that we can able to do. There is some mistake, I think, neighbors, yeah. And we have the option of flags. Usually it will be a 0, and then we will be giving that minimum size. That basically the first 3 are the mandatory. If you wanted to configure and get it good, we can give that other next 3. Basically, these 3 are optional, that can be given in case if we need it. Minimum size is something like object minimum possible object size. For example, I am here, maybe I taking that this image, it's showing something like 600 cross 600, and my face is around 300 cross 300. If you give that minimum size is 400 cross 400, then my face will not get detected basically here. And similar way, the maximum size is something like here I am having that around 300 cross 300. If I am giving that maximum size of the image will be 200 cross 200, then the image detection might not become. That was something like it's something like to detect a person. For example, when we install that face detection in something like a crossing area, then we can able to detect that face. Something like a lot of persons are coming. For example, some persons are coming from long, that also should not get detected. For that, we can optimize that minimum and maximum size in order to get that perfect closer persons in order to count it properly. Yeah. And we have that different supported informations from the Haar cascade classifier XML data. That is from that data. The link you can able to download. It has multiples of a classifier XMLs. Here we have frontal face, default and xi deduction, and then full body, lower body, and then upper body, and then we can smile. These are all the things we can explore in our lab. Yeah, nice talking to you. Yeah, we can see in the lab. Yeah, during the lab session. If you have any clarification, you can contact me at nvhariharan@nivitech.com. Thank you. Subscribe for more updates. Have a nice day.